really good at doing it this old-fashioned way, but because title properties like this were done on old DPs, it's useful for you to know how those old DPs were actually measured in the field. So you can imagine if a surveyor doing this surveys of some of the ones in this lot had their office in Penrith. They travel all the way from Penrith to do the job here. They don't want to have to come back another day. They want to be able to define the boundary, do everything they need to draw the DP, and even mark the boundary, then go back to their office and not have to come here another day. The modern way that many people would do this, they'd set up their total station here, measure whatever they can radiate, traverse up there somewhere, go right around the block and come back here, get their miss closed. Go back to the office, put it into CAD, do all the calcs, then work out where the boundaries were, draw up their DP, and if they had to mark it, they'd have to come back and put some marks in the ground. Or if something didn't fit, or didn't match with previous DPs, they might have a bit of a problem. So the old way, they didn't have a calculator, they didn't have a total station. Back in the 50s, they didn't have EDM, but they still managed to do a good survey. The fourth years, and some of them we'll talk tomorrow, during this term, they've done a survey, and a lot of the marks were placed in the 1930s. And they went out and remeasured them with modern gear, and everything fits beautifully. If you can find the old marks, the old surveyors usually do a good job. The reason sometimes we have trouble with DPs fit together is when you don't find the marks. Then things don't fit so. So we're going to start this corner here. And has anybody looked at the plans and know that these are aligned roads on them? Okay. Maybe not aligned. Let's just talk about what would happen if they're aligned. We go down here. There's an old sandstone curve. There's no alignment pins or mark here. But if this was an aligned road and somebody had dug up a bit which had the mark, the old plan, if it's an aligned road, you can see the dimension from that boundary to the curve, to this curve, to that boundary. And if the curve was in exactly the right place, you could use this to define the boundary. You just use the alignment and take the measurement from the sandstone curve. Now, not every curve on an aligned road is in the right place. And so they have a curb line, which is the official distance from the boundary, and another thing called curb laid or curb as laid. And in this case, it would be curb as laid. And it might even show you on the plan so many inches or so many centimetres away from the line. If you've got a plan like that, you can use this as a dimension to work out where that boundary is. Okay? What we're going to do is the offset method and try and run parallel to our boundaries. So, I have some masking tape for today's purposes because it stands out a little bit better. In the old days, they probably didn't use masking tape, they put a scratch there. Or if it was grass or somewhere, they'd put something like a zero nail. So you put that in the ground, and that's part of your temporary survey work. But today we're going to use the masking tape. So I'm going to decide to have a traverse line that goes parallel to this boundary, and another traverse line that goes parallel to that boundary. And if they're both set out parallel, then when I read the angle with my theodolite, it should match the bearing. So if I set the PO bearing up there, turn it around, I should get PO bearing down here. If I don't, then I know I've got a difference to PO. So I've got to work it out how I can set it out so that I'm parallel to the boundary. Then it's a matter of taking the measurements. On the plan, it says there's a distance from this to the boundary. And if you look it up, the boundary's out here somewhere, right? And it'll tell you so many inches, and you can convert that to metric. All make sense so far? Okay, someone want to help me with this masking tape? I'll pull in a volunteer, you're the closest. See if you can undo that. I've got another roll here. Sometimes they tear a bit. I could just get some texture marks out and put it in, but I think it'll show up easier for a group to see if I use masking tape. That's good. That's really good. So I'm just going to put it here for now, and I'd put a pencil mark on it or something. And I would choose a place that's comfortable for me to go straight up the boundary, and I might make it exactly 1 metre or some number like that. And I just pick a number and I write it in my field notes. But I don't measure from the wall. I've got to allow for the fact that the boundary's here. So whatever that distance is, I add it onto that to give me the mark here. Does that make sense? Yeah. I'm a certain distance from the boundary. I'm going to go up to the other end, just near the top of the hill. There's a laneway, which is our corner of our block. I can put a mark like this up there. So these are both the same distance from the boundary. So it's parallel. I could set up my instrument on this mark, and I could read offsets to all the bricks all the way along if I wanted to. So maybe at every corner, every fence, I might take an offset, and I can read it with a theodolite. And I can write that in my field notes, and I'll say, this next wall, you wouldn't take this one, but you'd go further up. You can measure the offset, know how far you're off the boundary, so you then can easily see how many centimetres in or out from the boundary, and you can draw that in your field notes, and they go straight onto your DP. Does that all make sense? So far? Okay. Our next question is, once I've got a mark up there, let's say I've already done that, how I'm going to read parallel to this one, I need a mark down here somewhere. There's a few different ways you can do this. One way is you set your instrument over this one, look at that one, and you plunge it over, and you put some lines down there. Okay? Now, what happens if it's really close? It's going to be hard to focus, isn't it? So how are you going to know where to do it? Well, so that you couldn't go out in the field, there's the chair now, without a plumb board. You know, Steve Bennett, who did that Sea-Cliff Ridge survey, he would talk about any of his field assistants that ever come out in the field without a field bag and without a plumb bob. He'd say that's the equivalent of, and I won't tell you the rest of the story because it's no longer correct to talk about those, but it got the message across. So you'd have a plumb bob, and if you put a few marks out here, so you could focus to here, you could string it back to where your instrument was, and you could get something online. Just practical things like that. You say, well, it's only a string, but you can do that within a millimetre or two, and that's good enough for a cadastral survey. So if you can't focus, you put it a bit further, and you have a mark here. Now you've got to decide where along this line you want to put it. Yeah. Similar to what we did coming this way, we can do the same sort of thing off this wall. We know so many centimetres. In this particular case, the actual boundary's out here, so it's an offset on both. So it's a little bit extra we've got to add. So I might say, with this one, it's nice to go up the footpath. So I'm going to put a mark here at a known distance that I'm going to make up. It doesn't have to be the same as that one. It's going to be convenient if I make it this distance, and I put that in my field notes. I'm going to go down the other end and put another one. I can set up here and toss it over. And you can see, whoa, this person is sitting up there, and he's sitting up here, and he's sitting up here. This is the way I much love setting up the instrument over a mark. But you get good at that after you've been doing it a long time. If you're a new student, the last thing you want to do is have to set up 3 times, right? So there's another way. If you don't want to have to set up so much, you just start here, put your instrument there. And then you look up there, and you're going to get an offset, and you have a 14 running back and forth, and you have 2 of these. And keep moving, you get the same number on both. That's the sort of thing we do with a party room. So let me explain that method. I set up here, and I can see it's going to be roughly that distance off. So I get someone to go up there, set that same distance off that wall, I take a reading, I'll come back here and see if it's the same or different. If it's different, I move a little bit up there, come down and see the 2 of them are the same. Then I know I'm paralleling this and what we've got here. And you'll probably get a number that's not 0.8 of a metre, it'll be 0.763 or something like that. But you can still do that. So you could just set up one, get parallel, and use this way and get parallel measure offsets. But if you're fairly experienced at setting up an instrument, this way is probably a little quicker if you can set up an instrument quickly. You toss it over, you come on this one, toss it over. Once you've got this point, you can read the angle. There's a lot to absorb there. Let's think about it for a minute, see if there's any questions. I drew a picture. So we've got a brick wall here. Our boundary in this case is a certain offset, and this one's a different number, but it's an offset there, and that's the corner of the lot in this case. We're going to put a traverse line up here, which is a distance from the boundary that we know. Now, let's call it 1 metre or something. This one here, we're going to have another traverse line, and it might be 0.8 metres from the boundary to there. Once these intersect, then you can read the angle. Okay? You don't need to do any calcs. You've got the PO bearing set here, you read it there. There are a few complications, but let's get the basics. Now, you can also measure distances along this line, and they would have done it with a steel band. They have to allow for slope and sag and temperature and all those extra corrections. But when you measure the distance from here up to this other traverse station, you're going to get this distance. What you've got to know is to subtract 0.8 metre from it, because this is your offset here, right? If it's not close to 90, then you can do a little correction for how much it is, but most of the time this is close to 90, so it's just this distance, and this gives you that distance. All right? We got all this so far? Okay, let me draw another issue. If there's somebody had put a drill hole and wing out there, or a GI pipe here, and given a bearing and distance to the corner, and that mark was still there, how would they do this technique? So we draw a page. So now we've got the corner, and we've got a bearing and distance to a GI pipe or something like that, and you found it. Now normally these days, someone would set up a total station here, they'd radiate that, and they'd radiate that. You know? What you can do for the direct method is you can calculate from the angle in here, you've got this bearing on the plan and this bearing, you can calculate that square, what this distance is. So you know the offset to this. And you could set up here somewhere, and you know you're that far away from it. So again, you can do the angles and set up, even if you've got a reference mark. That's the direct method of doing things. So you have to do a little bit of calculation in this case to work out the square offset. But apart from that, you could use the same method. Another way to do your survey would be to set your instrument on the pipe, the reference mark. And that's good if you can see anywhere. Sometimes you can, sometimes you can't. But it's always better to set up on a mark, like a reference mark or a corner mark, if there's no fence in the way, than actually just setting up somewhere random. It gives a better check. If you're on your reference mark and you do all your misclose of your traverse, you know you haven't made a mistake in your measurement because your misclose is good. You haven't had to do an extra radiation. Another option, instead of being sort of a metre from the wall, would be to come along the curb lines. And that would mean setting out there. On this street, with this traffic, I wouldn't be choosing that option. But on a really quiet street, sometimes you might take the intersection of the curb lines and set up out there. Nice and close to the boundary works better. So how are we going so far? Right? Well, let's go back to this standard one without a reference mark. And this site doesn't have any reference mark, of course. Going up here, we're parallel. Over here, I said, well, we had a mark down there. We tossed it over. So you're going to get sort of a couple of marks here. From this one coming down here, you say, well, string mark there, string mark there. And from this one, when they plunged it over, they had a string mark there and a string mark there. And it's a matter of working out where those intersect. And then you set up on that. That's the traditional way to do that sort of job. Because you can't have the instrument in both places at the same time. You've just got one instrument, one tripod, and usually just one assistant. So you string it through, set up there. Now if it's just grass or muck like that, sand and stuff, you'd be putting dumpy pegs or nails and stuff like that in the ground. Okay, so far so good. Now we get a real world problem on this job. We can see up there where that lane is just near the crest of the hill. We can do this line, no problem. This line here is a problem. There's a hill in the way. I can't see the corner at the other end. So I can't put, let's say this is a metre off, I can't put a mark there a metre off. I can't see it from here. I could go up there and put a mark that's a metre off, or whatever this number is, but I can't see between them. So I need a station in the middle. And that's called middling up. So you've got a mark here, even if you haven't got this one yet, you've measured this distance, you've got something at the far end, and from the middle you can see both. So you move your instrument backwards and forward, you may have done that sort of thing with Prac. So when you toss it over, you get 180 degrees, face left and face right. And if it's this one, then you know you're in the right place. Then you can put a mark on the ground, and you can come back here and toss it over. So you're going to move your instrument multiple setups. So you start here, get one in the middle, you set up in the middle, come back to here, and put your hand there. If you're experienced, it doesn't take you too long to get in the middle. If you're doing it for the first time, and you're out in the bush somewhere, and you don't have a nice fence to even get you close, then it takes a little longer. An option is to sort of roughly get here and turn angle. Say, well, it's pretty close to there, and that'll give you a mark that'll get you sort of close to setting up on line. There's all those little tricks to make it faster setting up in the middle. I've done it in rural sites where there's no fences or anything. You get a bit of practice, you get better at it, but you've got to be able to set up an instrument to do this sort of job. And that's the way they would have done these sort of surveys. Once you've got a mark in the middle with a bit of some sort of a survey temporary mark there, you can toss this over and get this one. Then you can measure the angle and you can measure the distance halfway. How are we going with all this so far? Now the students a few years ago used to do this. We'd have one group here, one group there, one group there, half a dozen different groups. But otherwise, if one group did it, with student speed, it would take too long. But even then, it took a long time. So I think you'll learn just as much when you talk. You learn it better if you do it, but this is a shorter time span. Okay. Now, the next question is, when the original survey was done and it said this is so many centimetres from the corner, was it rendered or was it brick? And the difference here, you can see the bricks down here and down there. They look to me like face bricks, the sort of bricks that people wanted to look at and see. The other type of brick is a common cheap brick, where you think, oh, we can just put anything there, we're going to put render on top. This looks like better quality bricks, so maybe this has been rendered later on. It's a pretty big job to render all the way around. So you've got to take a bit of a guess. Unless you can get a photograph from a long time ago to know whether it was rendered or not, you have to decide whether you want to offset from the brick or from the render. Well, probably only a centimetre or so, and people are not going to worry about a centimetre or so here. It's only when you've got to propagate a long way that things might sort of diverge. That's when you've got to worry about little errors. So you have to make an opinion and see what fits best. Well, 1 centimetre, that'd be rounded off on your DP anyway. So you don't necessarily show millimetres, so it wouldn't matter. But I wanted to talk about the concept. Okay? Any questions? We go to our next point. Someone want to carry my fill bag? The bits? Thanks. Let's go up here.
Shall we press play?
It's still recording, I think.
Or
18 minutes.
pop that out. Bruce and Craig got a press lecture. Did you get that?
Probably. I don't know how to pause it, so.
Random. What year's that come with?
Okay, just spread around me a bit. So our bottle here is our Trevor station and it's online. Okay, so if I was set up here, because I've done the middling over, when I'm looking at that end or at that end, I can take offsets, square offsets with the pocket tape. So I put the 0 there, or I'm at the instrument and the assistant's here holding it, bringing it out horizontal, measuring the offsets for all of these brick walls that are going in and out. It turns out there has been a recent survey in this area and they've put some drill hole and wings out there. For today's job, we're not going to worry about that, we're not going to use it. But if we were using it, we can measure to those as well from here. Got it? Okay. So this is like a temporary station. Now, if you weren't trying to be parallel and you're just traversing one end, you can put a station anywhere you want. And just read the angles and the distances both ways. That's what you're probably used to doing. And then you'll radiate all of these things and you've got to calculate everything. Well, all you really want to show on the plan is the offsets anyway. Okay, let's go to the next one.
I understand. Yeah. You still working at yeah, I didn't know. Road, Molly Road. Oh man, yeah, I've been in your area like I was saying for the last month and a half. The worst. It's like an hour every morning.
Yeah, it's got to take that out of there. So what we've done here, before we did the needling up, someone's come up this end, and whatever distance we were off the boundary at that end, we're going to come off this one. So let's say we've already done this. We've got a mark here somewhere. We'll put a mark on it, and we're going to have a traverse station. We're going to have a traverse station that probably goes up there. A bit closer to the boundary, offsets. Not too far out with a long offset, but you can get more sides a bit closer. But you've got trucks parked on line, you've got trees, so probably somewhere going up about here. There's a plan that says the corner of this is on the boundary. What's the problem with this? Where's the corner? So how does the surveyor decide? Is it this bit? It's not that. It's sort of here, or is it in there a bit, or is it down here? Or do you take it right at the base? If the fence is leaning over, like sometimes happens with brick fences, but also with stone ones, sometimes I lean, I'd be going fairly close to the bottom. This one looks fairly straight, doesn't lean over much, but it's still pretty vague. And that gives you an impression in the field. You can say, well, PO agrees with this, or it agrees with that, or it agrees with this. You can make that decision in the field, whether you want to change it from PO. If I was doing this survey and I picked that up, I would show the offset to it, but I'd also put something a bit more definite, maybe a drill hole, or probably a drill hole, not a pipe. But all these things all get dug up. How long are they going to last? But try and put something that's clearer what your mark is. If there's an SSM nearby, great, connect to that, because it's then connected to the control network, and if it goes, at least you've still got a connection. So I think I'd be adding a new reference mark off this as well. You have to decide. One way to make a decision is what they used to hold the plumb bob up and sort of eye it in, and sort of say, well, the average of that line sort of is here. The average of this line, we haven't got much to look at, might be around here, and you sort of say, well, that's about here, even though it may be worn off a bit and curved. So different surveyors would have different ways to pick that. But is the owner worried about it, or the person who buys this property? It's close enough for them. So as long as it's somewhere there, that's good. You don't have to show an offset on the plan. The original plan said it was on the corner, so it's on the corner. The only issue you've got as a surveyor is if you've got to push that somewhere longer. And if you take a little bit here and you propagate out and it gets bigger further away. But as long as you're interpolating, a little area like that's not a problem. So we had our distance here. We see the side in the middle. We toss it over, face left and face right, and we put a couple of marks here and here, for example, and they're both on a line. You could then measure offsets from this one and the next one and bring them straight down, or you can just pick one point here that's on the line and say, this is the point I'm going to do, what's the offset here, and try and turn your line until it's parallel. That's your choice. Either you can take the offsets, put a mark here and toss it over and intersect, like I talked about before, or you can just pick a point here and then move your line until it's the same offset at both ends. If you do it this way, you can have a nice even number, and the same even number up there, but you've got to do the extra setup and intersect it. If you just choose a point, then you're going to get a number. You can still write it down, just whether you want a nice even rounded off number or not. How are we going? Got it all? So you can all do the old-fashioned survey, eh? Well, as you practice setting up, that's about the only issue. But you can see where things fit while you're in the field, and you can draw up your DP and say all the offsets are already while you're here, and you've got the PO comparisons. Because once you've measured the distance back, you can take this offset off it, and you've got the distance here, see if that matches the PO. And later on we have another lane. If it was meant to be parallel to this, we can see in the field is it parallel or not, or are they too skew? Okay, that's about all from this corner. Let's move to the next one. You can see on this sort of a job, the surveyor's going to be walking backwards and forwards a bit, unless you've got a really experienced assistant who knows exactly what you're doing. You might be back and forward. Here you're going to have to measure an offset that we're going to make parallel to that one. And we've measured the distance, and you see the closer we can get to it, the more accurate we're going to get a level distance. You see the problem here with the render? It's getting a bit thicker here, and it starts to push your angle a bit. You come there or that, you lose this marker in or out, it's going to change that angle a bit, and you get the propaganda plane, and it all starts to accumulate. On this particular plan, there's a distance across the lane to that one there. You can get a longer tape out, 6 metres or something it is. Use the plan's distance to what they used on this surface. And then you can say, was it the render or was it the brick? Has this thing moved? So once you've worked that out, then you can probably assume it's the same if it's this or if it's that, to take your offset that way. So I'd be getting the tape out and measuring across to this one and see what the previous surveyor used. How long will this last? Is this still going to be here in 100 years' time? Maybe not. Look at all the properties around that are getting knocked down and pulled out. Good chance this will go. Apparently there was a plan that had a GI pipe reference to this corner, and the students were doing some measurements, real measurements, and they dug up the pipe. Well, that's the story anyway. Pulled it out of the ground. Don't do that. I don't know if that's a real story. No, that's told to me by Michael Green, who used to teach us. A bit of history about Michael. He was employed by the uni half-time. So he'd come in and teach land development and cadastral subjects and a couple of other things that we used to do we don't have courses for anymore. And the other half of the week he'd run his own business doing cadastral surveys. That's the ideal sort of person we want. But the uni won't let us employ him at the moment. And he's retired a while ago anyway. Okay, so I'm just a temporary fill-in until we get another one like Michael. So we've got this, we've done our offsets. We can sight back to that one. Oh, I haven't told you how to sight back, have I? We used to have things called sighting tripods, which are really lightweight tripods with just a plumb bob and sticks basically, and a little spike on top. You can measure the distance to the top or the distance to the ground, and you can sight to it. It's called a sighting tripod. So they're easy and light to carry. You could leave one down there. If you can see to the ground, the other option is use a red and white. So if I had a mark, I'd do the same thing down there. I'd bend it over, put it on a mark, hammer it onto, stuck onto the concrete, or put a nail in it or something, hold it there, and I can sight back to the red and white instead of having an assistant running back there to read the angle. But with a tape, you're going to have to measure the distance, measure the zenith angle, calculate the horizontal, all that sort of stuff. So that's the way they would have done it. They'd have left back sights that you can sight to them. So now I'm set up here, sight to that one, toss it over. I'm going to have to make a decision where to put my traverse station so I can go up there. If I just leave it here, I'm not going to be able to see. So I need an offset. Come out here, you've got to watch the traffic and everything else. You want to probably be pretty close to here. If you look down there, you'll see there's a brick building. And it might be pretty close to the building, to the boundary, and it's fairly new. If you don't come far enough, the line might go through it. So what you do is you estimate out here a little bit where it's going to be safe enough. You set up, you read the angle and see how that wall looks to start with before you go too far. So at this site, we've got a brick or render issue. We've got a check measurement that helps us. Also tells us that's movement. And again, I'd be putting something a bit more permanent here, or somehow connecting like for the lighting. The fixed stations up on top of civil building. Take a shot to that these days. Get some extra connections. Right, those things disappear. Leave a legacy for the surveyors to come later on. The more you can connect to things that are going to stay, the longer they stay, the better everything is. So we put another mark out here, and we look down here, either by turning PO and reading it, or going down the other end. But on this one, we've also got a hill, so we're going to have to middle up. So you might have a temporary one here, put something in the middle, backwards and forwards. You can see a lot of walking around, fiddling backwards and forwards. The more experienced you are, the quicker you are doing it. Questions? Okay. Let's go on to the next one. The bigger the group, the slower we walk. Yeah. Okay, for the purposes of today's exercise, we're going to assume that the extra bit of road that's been claimed as road, the extra survey near, we're going to assume that doesn't exist. So there's just one straight line boundary from that corner down to this corner. And on that corner, there's a brick that was shown on a plan how far it is off the boundary. So we can take an offset on that one. We have our offset on that one. If they're the same, we're going to set up here. Now, my looking at this would think that this is going to be pretty close to our boundary line. So I want to set up a station, maybe somewhere sort of here that's convenient, where I can take a good offset for this and show it. It's a couple of centimetres onto the road, or it's a couple of centimetres clear. There's the boundary. I can measure that straight away and know. So from here, it's doing the plunging and moving back and forwards until I'm on line. Then all I would do is measure the distance both ways. I don't need an angle here because it's on the line. But I need to leave something here as a target, so when I get down there, I can read back to this to propagate the angles or carry bearings. Extra feature, if you're doing this survey for real, you'd probably want to define the other side of the boundary of this road. See if it fits or not. It turns out, over the years, there's been some DPs in that area that we know are hard to fit. So we're going to not worry about it today. On a real job, you'd have to probably worry about that, or maybe some surveyors would just ignore the other side of the road because it didn't fit. But if you can connect things like that, it does help build the fabric of the cadastral later on. So this is similar to what we did on the other road. But by now, we can, once we've set this up, we can go back there and read that angle. We can see if this road is parallel to that road, if it's meant to be. Down to the next one. You see, someone's put a little wing on here. And from memory, the corner of this brick is on the boundary. It's shown by plans that this wall and this wall are both on the boundary, and it's not rendered. Don't know if that was built the same era as that one, but it looks a similar sort of brick. Before, when we were down there, we had our assistant come up here and put our distance out here, right? That was the known distance, and that's what we used when looking up here. Now we're coming this way. We've measured an offset from there. It's going to be in here. And my masking tape's not going to fit it, and I'm going to have to try and set a tripod there. A bit tricky. Well, that's the sort of thing that sometimes. You've got to sort of set the tripod up so you're the right distance from here. Then you somehow got to toss it over from that line, put some marks out here. On this one, you look down there and toss it over, and you get these. A bit tricky in the sand and gravel and post in the way, but that's the sort of thing that they have to try to do. If they couldn't manage that, and they could at least see a plumb bob here at the right distance, you could put another mark in there. But you'd have to make sure the person is still at the input there. So you say, this is going to be no good. Look at it, the offset, the tape, move me online with the plumb bob, put a mark there. Does that make sense? So I have that one, which is still parallel to that boundary. It's just not right up here at the corner. I would measure it with the tape and hold it with the plumb bob, and then they put another one. I can set up there, I can toss it over, I can toss this one over, and then I can read this closing angle. It checks my angle on this closing my traverse, and also shows me how it fits with CO. And I can get the distances. Now I've got this offset, and I've got that offset, all those things I've written down, so I can get the distance from here to the traverse station minus these offsets. These days you can connect it to NGA and skims marks and everything. In the old days, even before we had any of that sort of thing, these buildings might not, they'd have been there in the 1950s. The surveyor might see there's a church fire before that tree grew up. An old surveyor might have taken an observation from it. This particular plan doesn't look like that. But sometimes, especially in rural areas, if there's a good prominent church spire or a trick station, sometimes in the field, in the DP, they'll even give you a direction. That's all that information. If you're going out doing a survey these days, I suggest you do that sort of thing. Help the next one that comes along. You don't have to all the time. Sometimes you do a little bit extra, and it helps everyone. Questions?
Yeah. On the DP, there's two lines showing for this corner. There's a line like going this way, and there's a line that squares it off.
Oh, okay, so there's the. Yeah.
But that's giving it join between.
No. Sometimes on some properties the boundary is not a rectangular corner. Sometimes there are splayed corners. And so this might have been built, and it might be a later DP or something like that. The original boundary might have been from there to there. It's unusual to have on a lane. And why would they build that? This is actually built on the road, because the road's there. And we're just going to ignore that one for the day. But that sometimes does happen. The boundary should be back there and back there. This is on the road. And if that's the case, if that's the boundary, you've got to show that on the DP, say it's on the road. So this lane, is, if we call that a road, and we call this a road, the boundary for that road is up here, not down there. Good question. Anything else? I think that's about all we wanted to cover today. Oh, there used to be, this is a new path here, just about a few metres down there, and I've got a photo of it in your notes somewhere. There were two drill hole wings about this far apart. Down there, one there, one there. What's going on here? Did they change their mind and come back? Why don't they just change the dimensions? If somebody come and probably the people doing this survey down there, where we've got some problems with, they didn't fit with one, so they put another one in? I hope not.
Above 3 on the single driveway.
3 on one driveway?
Yeah.
Who knows why?
Who knows what it is?
If it's a traverse station, they probably wouldn't have put a wing on it. That traverse station might be just a drill hole. Like I could put a drill hole here. But if I'm going to do a traverse these days, and I'll put a traverse station here, then I'll put a drill hole and a wing, and on my plan I can show a bearing distance, even if I've done it this old fashioned way. The more traverse stations you use as reference marks, the better. And another surveyor can say, oh, I can set up on his reference mark there and his reference mark there, and go from there. You don't have to put new traffic stations all the time. If you've got a reference mark, it's convenient, use it. It's a traffic station. Good? Anything else? None? That's it for today. Now, we've got a lab session.